Hi guys, my name is Greis. I hope you're doing well and I welcome you to a new video. While ordinary smartphones always look like the following here, just like a candy bar, so in a 16:9 or 16:10 aspect ratio, over the recent years, new device approaches came alive. So nowadays, we also have to work with adapted screen sizes that can maybe come through a so-called foldable device. So in my hand here is a foldable device that you can fold horizontally, but you can also have the other way around, so a vertically foldable device. Luckily for all those iOS developers out there, these foldable problematics are still an Android only problem. But in the context of Android development, how can we support those adaptive screen sizes so that we have an app that looks good on such a single device, but also dynamically if we open up a device and the screen gets big. For showcase purpose, I created a little example repository you can look into. The GitHub link is down in the description. And in this video, we'll walk through the essential steps how you can create your own adaptive screen layout. If you want to support foldable devices, but you don't own an own physical device, that's no problem. Android Studio, meanwhile, provides also emulators for foldable devices. So just go to your device manager and then create device. Go to phone and just search for fold. And here you can, for example, choose fold in without a display. So you have two displays in the inside and one at the outside. So just to take a look at that again, that's exactly the same like this device here. And just shows next and select a system image. Click once again next, give it a good name and then finish. And just to quickly showcase you what we're going to build here, this is the app in the regular state. So in this candy bar state, I have here some sample nodes. I can go into a node and read the full text, and I can also create a new node. So let's quickly do that. So you see it appears here. We have here a bottom bar with just two tabs. And now the magic happens if I click here in the fold unfold button. So as you see, a new window opens up and we have here a 3D model of the device. And now I can just click open here. And as you can see, the device unfolds. So now we have a 2-pane layout instead of a 1-pane layout. And that is exactly the adaptive part here. So now I can just click here once again a node and the detail view appears at the right side. So I don't have to navigate. I have all the things at one display. And additionally, you may already recognize it. You can see that the bottom bar switched to a navigation rail. So this is the side bar here and also the action button, which creates a new node. Move to the navigation rail here. So when I click here, I can once again create a new node. Let's quickly have an overview about the project. We have a regular package structure here. So UI layer, domain layer, and also data layer. For this part, data layer and domain layer are not the layers we want to talk about. It's solely the UI layer. And here we lie the features that are effectively responsible for allowing us to use such a responsive or adaptive layout. Two things are essential for us to implement this adaptive layout. One is the accompanist package, which allows us to use the 2-pane layout. And that is what we saw with these two panes. One is the list of nodes, one the detail node if the device is big enough. But how do we know if our screen is big enough to show an expanded layout? Here we can make use of another package, and that is, if you take a look at the dependencies here, the Android X Compose Material 3 window size class package. This package provides us the calculate window size class, which requires the activity, and it on the other hand returns the window size class. And this window size class provides two things. One is the size class of our width and one of our height. For each of those classes, we have three options we can have. One is the compact mode, one is the medium mode, and one the expanded. So if the device is in this collapse mode, it's in the compact mode, of course, and respectively, if the device gets bigger, it goes into the other states. So with the help of this helper composable, we want to create our own simplification because we only want to know, is our screen in the collapse mode or is it in the expanded mode? And depending on that, we later want to adapt our layout. So let's start with a new composable. We call it isWhiteDisplay, and as an input parameter, we need an activity, and we can use the default parameter, and we can simply use the local context.current as activity, because I know that this is a single activity application, and at the top level, let's ensure that there is an activity so I can just cast the context to it. The next thing we need to do is now that we say window size class, and now we can use the helper class from the Material 3 library. So calculate window size class, and here we now use the activity as an input. And now it is unlighted in red because it's experimental. So we say opt-in and we are fine. We can also put it to the top here and say file opt-in, and then we can just use the experimental class here. So we later don't have to opt in again. Next, we introduce a new variable and we just call it like the function name isWhiteDisplay. And then we say here by member and use a derived state of. And we will do a quick calculation here because we just say window size class and we want to know the width of the size class is greater or equal to window width size class medium. So that is the point where we say, okay, our display is currently in the width state. And the trick here is that this will update as soon as the screen adapts. And we will always know on the runtime if we are currently in the expanded or collapsed mode. So now we just return here this isWhiteDisplay, change the return type to Boolean, and we are done. Next, in our main activity, when we set the composable content, and we have here a simple example theme, and also we're using coin. That's why we're having here the coin Android context. And now we can access our isWhiteDisplay by just calling isWhiteDisplay equals isWhiteDisplay. So we access here our composable, and we can also just insert here the reference to the activity because we're in the activity anyway. And now we say nodes app and put in here the isWhiteDisplay. And the nodes app is the composable that will be responsible for deciding which layout should we at the end show. So we use here state hoisting and bubble down the isWhiteDisplay to another composable and say nodes app content. And here we can once again use the isWhiteDisplay. So just pass in that. And now we come to the interesting part, because as we already discussed, we want to show either a navigation rail or, on the other hand, a bottom navigation if we're in the collapse state. I already prepared those two layouts. The first thing is here, the bottom bar layout. It only contains a scaffold and here the app navigation bar. And this app navigation bar is just a regular navigation bar, as you might already know it. And we use here a helper class called tab, which is a custom class. So let's go into that. As you can see, we just have a destination, icon, and a label. And then we have a persistent list of all the tabs we want to display. So in this case, the nodes and settings tab. And for both of our layouts, we use this list here to render at the end the navigation items. So for the navigation bar, of course, we have a navigation bar item. And for the navigation rail, you can quickly go into that. We, of course, at the end have here the navigation rail item. So, and if you also scroll up here, we can see that it's just the regular navigation rail composable, which comes from material 3. And then we have a header, which is the create node navigation destination. And here also as a header, as you saw it, we have the floating action button, which navigates to the create node dialog. But that just as a quick wrap up, you can look up the code in the GitHub repository. And now to the actual part. What we want to do is now that we have one app content that is passed through these layouts regarding on which of these should be shown. So we don't want that all our layouts get re-rendered, but we want to save our state. But how can we actually do that? First, we create a new variable because we will be saving our navigation host inside a variable. So we call it navigation host. And then we say remember. And now we introduce a new composable, which you might not know, which is the movable content of. And what this movable content of here does is that regarding which composable you declare, it gets assigned to an ID. And if the place of this composable switches from one place to another, all the remembered states will be passed to the next state with it. In this case, we will use the destination nav host, and we can use here the navgraph.root. So this is our top level nav graph, and then we only need to add a nav controller. We can call here remember nav controller, which will be passed down to our layouts in a second. And additionally, besides of assigning the nav controller, of course, we also need to introduce a modifier here. And this modifier will get a padding. And because the bottom navigation has a scaffold around it, you may know that you are required to pass down the inner padding of the scaffold. So if you have a top app bar, the content, for example, will be adapted accordingly. So let's do that. We say here inner padding and assign that to the variable here. And then we say here padding values. And as you can see now, the lambda changes here. The next thing we want to do is that we decide, are we currently in the white display? And in that case, we want to show the navigation rail layout. And here now comes the nav controller into play, because by that we can navigate to not only to the tabs, but also to the create nodes destination. And then we also want to have the next layout, and that is the bottom bar layout, which we talked about. This also needs the nav controller. And now in both of these cases, we can simply call here the navigation host and put in here the padding, which we have here in this lambda already. So we can say in a padding, and sorry, in this case, we of course have no padding, so we just call padding values. But in the case of a bottom bar layout, where we have our scaffold as we just discussed, we can use the inner padding here and assign the lambda value. So let's make the type explicit, and we are fine. If this is white display now changes and goes from navigation rail, for example, to bottom bar layout, depending on if the device is open or closed, the layout will change and the navigation host here will just change its position. In our layout, we have the nodes tab and also the settings tab. The settings tab is just a ordinary screen that has one size, but the nodes tab has the adaptive layout. So for the nodes tab inside the code here, we need to tweak it a little bit. So we say, once again, here, composable, private fun, nodes content. And then we say here, we call nodes content. And what we want to do here is now we want to know when should we show the two pane layout and one the collapsed layout. And we previously created this is white display composable, which we can now just reuse and say, if we're in the expanded mode, we use the two pane layout, but if we're in the collapsed layout, we, as we already said, will be using the regular navigation. So we say here once again, show two pane layout, and we can use the is white display. And here we this time leave the default variable here inside to the activity by the local context.current. And now we pass the show two pane layout to the nodes content. Of course, we need to declare the variable here. And then we can just say, if we should show the two pane layout, show two pane layout. But if we are inside the collapsed layout, then we use the destinations nav host and say here navgraph dot nodes. So this is a nested nav graph which only contains the nodes destinations. So in our case, the overview and also the details view. And for the two pane, we say two pane node screen, and inside the new file here, found two panes screen. And we also want to use state hoisting once again. So we also declare two panes content composable. And then we need a new view model, the nodes two pane view model, which I already declared. So we just have a nodes two pane state, which on the other hand only contains a selected node UID, which will be the selected node for the detailed screen. And then we have a state flow here and also a function to select a new node UID. So when we go back here, we can use here coin for dependency injection. So our view model gets automatically created or injected here. And then we can call the two panes content like that. And we also need to collect here from the view model state, and we can use here the collect as state with lifecycle. And you see the by keyword. So the state directly gets evaluated, and then we can pass in the selected node UID. Of course, we also once again need to declare here a variable which is called selected node UID, which can also be null, or let's leave it like that. And let's use a name. And we also want to use on select node UID, and in this case we call the view model, can use here lambda to reference the select node UID. And which is wrong here, found UID. Okay, of course this is UUID, not Boolean. Sorry for that. And then once again we use here the on select node UID function, which on the other end can only be of the type UUID, and it's the function reference here, or lambda. And then the next thing is that we create the two panes layout, and for that we reference the accompanist two panes layout. So say two panes or two pane, and now you already can see that we not only have one content lambda but two. So in the first lambda we put in our left side screen, and in our case that is the nodes overview screen. And here we say on show node details, and as you can see it's lambda that just selects the node details. And so I just use here the reference, and the second one is here the nodes details screen. If we go inside, you can see that we have here a nodes UID, which can be null, and depending on that the view model gets injected or created with this factory here from coin. And we have one entry point that is just solely the screen, and the other one is from the navigation. So that way we can use two different entry points. One is, like I said, from the navigation, of course, and one is from our two-pane layout. The handling here of the UID is made manually. Of course, there are other options to do that, but that is just a showcase here, so we don't worry about that. In this case, we pass in the selected node. What was the name again? Node UID. And so if in the nodes overview, if we go inside, one node gets selected. Here's also the case that we have a navigation entry point and one that is only about the screen here. We just call the function here, and instead of that, this function gets passed to a new navigation route, or a new navigation route gets invoked. We are just inside our two-pane here and pass the node UID to our two-panes content. The next thing we need to do is to define a strategy. And because we only support a horizontal layout here, we say horizontal strategy or horizontal two-pane strategy. And here we can define additionally, or need to define, a split offset. And the split offset is, yeah, the middle of the screen. So if we once again go back to this foldable here, the hinge here, or the middle of the screen, is essentially the fraction. So if we say 0.5, it's exactly in the middle. And depending which direction you want to go with the content, the first one is, I think, less visible if it goes further to 0, and otherwise, or the other way around, the second one is more visible if the number gets bigger. Let's go for 0.5, and then the last thing we need to do is to pass in the display features. And for our case, we just use a function here from the accompanist package once again. So let's say calculate display features, and here we need to pass in an activity. So let's quickly get that again. Activity equals local context.current as activity. And then we can simply pass that in. But one thing is missing, I just realized, and that is the folderware configuration. Because we only, as I already said, we only want this strategy to be apply to folderware horizontal folds only, and not to vertically devices, because the layout is obviously laid out for horizontal devices. But if you might want to support a camera app, if we come back to one of my earlier videos where I showed how to implement a camera app, you might want to have the camera in the upper layout of a flip phone, for example, and at the bottom only the camera shutter button or something else. So yeah, finally we need to go back to our notes tab and place in the two-pane screen here. So if the screen adapts when folding it, we either show the two-pane screen or the destination nav host. And if the navigation setup here might look little bit weird to you, don't worry, it's just the composed destinations library. If you never have heard of it, I can only recommend you to try it out. It's based on the regular Android X navigation library, but it provides a type-safe way to navigate. So you have a KSP compiler plugin and use some annotations, and as you already saw, you get those type-safe destination objects where you can just navigate to. So maybe it's also a topic for another video, but just that you know what we're talking about here. And yeah, that way you can support foldable devices with those little helper packages. And yeah, at the end, it's a lot of work you need to do if you have a big app and want to fully support it for foldable devices, of course. But maybe you have a smaller app and can afford it to bring in some support for that. I mean, it's not impossible to do, but as you saw in those notes examples, I had to create a composable screen on which the logic is not only usable for having this single entry point, but 2 entry points, and also need to handle the state in the outside. Of course, you maybe could also use another view model or something like that and share that with those screens. But this is just a showcase, and of course there are also other options how you could do it. So what's your opinion? Are you already owning a foldable device? Did you already develop some apps that are responsive to those foldable screens? Let me know in the comments. And as already mentioned, I just showed a snapshot of the repository. If you want to have a deeper look into it, just go into the YouTube description here and check out the GitHub link. And as always, I hope you had some takeaways. Like the video, subscribe to my YouTube channel, activate the notification bell, and I hope to see you soon.